Yo. Can you hear me okay?
I can. Can you hear me?
Oh, I can.
There we
Success.
go. Let's go.
My job is already done.
Yeah, exactly. Yeah, it was being weird. It wasn't letting me respond back to you in our thread. It was showing like drop files here. Okay, now it's not there. But I'm like typing and it wasn't working. I'm like, what is this?
What's happening?
But
Yo.
What do you need?
But
What's not working this time?
Everything seems fine. I don't have any video. Mine is very straightforward, which is great.
Okay. But we can hear.
Yeah. So
Hi.
you can hear me.
We
I'm
can hear,
alright.
and he can hear you.
Yep.
And then when you share screen, you don't have sound on videos that you're saying. Because some people have to share audio, but you're not doing that, correct?
No.
Okay. And then you're just going to share screen of that screen. Okay.
Yeah.
That's
we'll
great.
see.
That's the best way to do it. Yes.
Let's see how it looks.
There we go.
What do you see? Do you see the full screen as the?
I do, yes.
Oh, good.
Are you able to click through, Brendan, or does it not let you?
I have to request control. I had ran into an issue with this earlier where I could, but it wouldn't sync with Napoleon. So like I would click through, but it wasn't then clicking through on his side. And then it got goofy at the beginning where I wasn't clicking, but then it was stalled out on the first slide. So
Okay.
I think it might be best that Josh, if you want to just handle that, I think that might be good.
So you just tell him when to go to the next slide, or just point at him, say next slide. Okay, sounds good.
Oh, right. Yeah. The first part.
Is that
the first? Yeah, that's pretty easy.
Yeah, totally down.
Okay. Yeah, it's not that hard for the slides.
I've got
but
my Teams open. If it gets really bad, you can drop me a Teams message.
Okay, perfect.
Okay. Sweet.
Easy enough.
Running your guys' section too.
Sweet.
Okay, thank you.
Thanks, Mariah.
Thanks, Mariah.
Thank you.
Brett, what's your are you from Utah originally?
No.
What's your
far from it. Minnesota originally.
Nice.
And then basically I grew up basically on the North Dakota Minnesota line. So like half the time I say I'm from Minnesota, half the time I say I'm from North Dakota. But I
sound rural or not kind of thing.
Yeah, exactly. You know, if I start talking about hockey, I always talk about Minnesota because I played hockey growing up. But then I was actually out of college. I went to NDSU in Fargo, which is right across the border from Minnesota. And that's after college, I started out at Microsoft for 5 years because Microsoft has a very big sales hub up there, which you don't believe that, having a Microsoft presence in the middle of nowhere. But yeah. So now I'm in Tampa, Florida, though. And a very long story of how that happened, but so another time for that. But
yeah, because you were in Utah for a minute there, right? Or were you just
I was basically visiting, when I first started. Yeah, nice. I came out for like a month and a half and then was back here for 2 months and then back out there for a month and then one other trip out there. I think it was just for a week, but
did you guys get the hurricane in Tampa? You did, right? Wasn't that on the?
It was south of us. We lucked out big time. Yeah, that week was crazy. We had to mandatory evac or the zone I'm in, and we went to Orlando to my girlfriend's friends, and the hurricane took a last minute curve and basically hit more Fort Myers area, which is only an hour and a half south of here.
Yeah.
And pretty thankful and blessed to be here because it was supposed to be a direct hit here and it completely missed us, which was pretty wild. But I've gone from dealing with blizzards up north to and the frozen tundra to hurricanes, but definitely thankful.
Wow.
We missed.
And have you adjusted to the new environs, like temperature wise? Like, are you? I'm just well, I mean, you've got humidity in both places, so you're used to that, but the temperature is a lot different.
Very different. I'm so confused right now with it being November and it's, I think, 85 today out.
Wow.
And I mean, we got a low cold front after the hurricane, and it got down to like 60, which was kind of chilly. But
Yeah.
yeah, back in the 85 and just loving it. So I'm a baby now when I go back up to Fargo. That's for sure.
Oh, for sure, dude. Oh man, I have some. My in-laws serve missions for our church, like in like Pacific Islands.
Oh,
And
sure.
like they're from Wyoming. They live in Wyoming now, and so they're the biggest wusses ever because it's always cold in Wyoming.
Yeah. Yeah.
Like seriously, except for like 2 months of the year. So yeah, they're huge wusses now.
Yeah. Yeah. I get made fun of a lot now. That's for sure.
It's real.
But
let me go snag a drink really quick.
perfect.
I'll be back.
Sounds good.
Just block my video in case anyone joins and is confused.
Hey everyone, thanks for joining. We're give it a couple more minutes, so 15 minutes after the hour, and we'll get started. But thanks for joining with us so far. Hopefully you guys are having a great Business Technology Summit already. I put in some links to our social media. Love to hear any feedback you guys are having so far, and good, bad, right? And if you guys are having a good time learning a lot, love to hear about that. But like I said, we'll start at 15 minutes after the hour. So a couple more minutes, let some more folks filter in here. All right, Josh, you ready?
All ready. You hear me okay?
Perfect. I can. Awesome. Well, I'll go through some housekeeping items here. Again, welcome. I am Brennan Johnson. I am hosting this session. So this is your first one. Welcome. If not, hopefully you're having a great time already as we're hosting our Business Technology Summit 2022. We are JourneyTEAM. This session specifically is around Power BI, data modeling within Power BI. So very excited about that. Josh, if you can go through the next or hit the next slide, I'll go through some housekeeping items first. This session is being recorded and will be available to attendees after the event. All attendees will be muted. If you have questions, please put them into the chat and we will respond to them either during the event or at the end. We'll make sure to hopefully leave some Q&A time at the end. If you have any connection problems, please use the chat or contact our event support at support@journeyteam.com. And the big one, near the end of the session, I will be putting into the chat a short survey link. Please fill that out before you head out. That link gets your name into a drawing for a $50 Amazon gift card that we're doing for each session. So that's why it's important to fill it out before you leave. And you'll also be put into a drawing for the new Sapphire Surface Pro 9, which is very exciting. Josh, next slide. So JourneyTEAM by the numbers, we are at 130 employees strong here at the moment. Over the last 12 months, we have 350 active customers. We've been around for just shy of 30 years now, which is awesome. Our referenceable rate with our customers is fantastic at 90%. And a big one with Microsoft is how they kind of grade partners, as there's thousands of partners out there in the whole Microsoft ecosystem. We have 4 solution partner designations, meaning we know what we're talking about. We have the expertise, which is great to have. And over the last 5 years, we have completed over 1,300 projects, which is fantastic. Next slide. Some accolades that we have out there, Inner Circle Award, which is great. That puts us in the top 1% of business application partners. Partner of the Year awards, some best companies to work for awards, which is great seeing that as we continue to grow. Next slide. I know this is kind of a lot, but as we all know, the Microsoft stack and the ecosystem is huge. What's great is a lot of them, all the different platforms work together. This one specifically, we're talking about data and Power BI, right? But it just goes to show that Microsoft is huge across the board, but these are all the areas that JourneyTEAM, we have experts in. With Josh, talking about Power BI in this one. But if you have questions of obviously Power BI, we have that resource with Josh. But if you have questions on other parts of the whole Microsoft ecosystem, we have those resources as well. And that's why we like to kind of flash this slide out there just to help kind of break things down and show how all the different things work together as well. And with that, I'm very excited to introduce Josh. He is our Senior Business Intelligence Consultant, very well known within the business world with Power BI, right, and has great expertise. And with that, Josh, I will let you take it from here.
Cool. Thanks, Brennan. Or BJ. I just heard someone call you BJ. I'm like, oh, I didn't know. But this is BJ. He's the man.
Yeah.
Appreciate that introduction. So
Absolutely.
I'm Josh Jenkins. Here you can see me in frozen form in a business office world. And here you can see me in a less frozen form. Alas, I'm a senior business intelligence consultant here at JourneyTEAM. Been here for a few years now. Prior to that, I was doing operations at a large corporation. And part of that, I was in law school because that's just is the perfect path into technology, obviously. So I've got an interesting path. Another interesting thing about me is I'm just a huge geek. Just like 2 days ago, my wife told me, you know, there was a time when I broke up with a guy because he was just too geeky. And then somehow she ended up with me, and every day she's just shocked by how geeky I am. But nonetheless, that's just a little something about me. Let's dive in. What do you say? I wish we could have a little more dialogue. If you do have comments or something you want to say, make sure you drop it in the chat, and we'll answer that. Ideally, as we're going through it, if it's something that we need to delay on, then we'll get to it a little bit later. But so here are the course objectives today. Really, what we want to do is answer the following questions. Why does a good data model matter? You might have asked yourself this at some point in time. What is a data model? That's a very basic place to start. What are different types of data models within Power BI? How do data models work in Power BI exactly? What are the components of them? What makes a data model good or bad? And lastly, how do I actually build a good data model? So this course, we're going to answer each of these questions, but it's going to be very high level. We only have an hour together. And unfortunately, data modeling in Power BI tends to be the most complex part for a beginner, just because it's just such a new concept, especially if you're coming from another BI tool. It's so different typically that it can be a rough learning curve. So what we're going to do today, again, is just kind of cover the basic concepts as much as we can. Again, yeah, so a lot of content to cover. Not going to dive too deep, not going to do any demos to like really dive in and show you exactly how to do everything. We do have a course for that, which we'll provide you the information for that afterwards. But essentially, we've got a course that'll help you dive deeper. We'll have the kind of workshop kind of stuff where you can actually go in and do stuff. This is going to be really high level. So first, why does a good data model matter in Power BI? Well, with a good data model, reports and dashboards are performant, meaning they refresh quickly, meaning the data will come into it quickly, as well as the visuals will populate quickly within Power BI. With a good data model, reports and dashboards are easy to build because a model is more intuitive, so it's easy to know which field to grab and pull into a visual. Those kind of things. And also it's more durable, meaning over time, as I'm getting more and more data, like if I'm looking at sales data, I'm expecting and hoping for lots more data, more sales and data to come in. And I want my data model to be built in a way where it can handle more and more and more data for a long, long time. And that's what a good data model does, is it'll last for a long time, no matter how much data you're dumping in. Now, to go a little bit further too, why does good data model matter? There are three main influences on Power BI report performance. When it comes, like, at the end of the day, people who are using Power BI, performance is a huge part, right? Having your numbers right is obvious. Like you obviously need to have your numbers right. But if things take a long time to load, that completely negates the entire purpose of the report. People will not look at it, not utilize the reports and gain the benefits that having good information actually gives people. There are three main influences on the speed of a Power BI report. One is the data model size. Another is the data model infrastructure. And the last is the complexity of the queries that I'm running against this data model. On data model size, means how many rows we have, how many columns we have, what kind of values are in those columns and rows. Data model infrastructure is like relationships. These are things that we're going to dive into a little bit deeper. Then complexity of queries is just how complex of a question am I asking? Am I comparing data from different years? Am I doing a YTD? Different things like that. Depending on the complexity, it can influence the speed of my report. Now, what is a data model? Essentially, it's a curated index source of information. That's really a way to think of it. It's the place where Power BI looks for information. And if you've opened up Power BI, a PBIX file or a Power BI desktop file and go to the model view, this is something like what you'll see. So this is a data model in Power BI. Specifically, we're going to be looking at imported data models. So best case scenario is typically to use an imported data model, meaning I'm not using what's called direct query, where each time my visuals are refreshing, I'm going all the way back to my source, which could be a data warehouse or a database, maybe on premises or up in the cloud. Instead of having my source be out there, what Power BI offers, it allows you to pull that data right into Power BI, so there's no latency between the source and my visuals. It's all living right inside Power BI. So, and that's what we're going to be addressing today, is an imported data model. And this is an example of an imported data model. If it was direct query, we'd have little blue lines at the top of these. Not a huge difference, but nonetheless, just want to call out, we'll be talking about imported data models. Now, why do you even need a data model? Fair question. So with a data model, you can populate your fields pane in Power BI. And with a fields pane, you can then create visuals. And if I don't have a data model, I don't have a fields pane. If I don't have a fields pane, I don't have visuals in Power BI. So I absolutely need to have a data model or data that I can actually reference for visuals. It's pretty intuitive, but worth a call out. So what are the different types of data models within Power BI? So from a general concept, we're going to talk about two of them. One of them is a flat or denormalized model. Think of just a big spreadsheet, right? This is a big old spreadsheet, and this is my data model. This Power BI totally allows this. And if you're coming from Tableau or other great reporting tools, most of them require that you have a flat or denormalized model, meaning I've just got one big, oftentimes it's a SQL query that's given to you, or that you wrote yourself, right? But it tends to be just one big table that has all the data. Power BI, unlike most BI tools, allows a relational model, meaning instead of just having one big table, I have that information broken out into multiple tables. The advantage being it takes a lot less data. It takes a lot less space in my model, but I can still get the same information out of it. So instead of having my relationships established row by row here, right? Like here, I've got this country and zip and customer. I can see the association between these because they're all in the same row. Instead of doing it that way, we break it out and have relationships established via keys. Is essentially what's going on here. And we're gonna get a little bit deeper into that, not too deep, but a little bit deeper into that as we go. But when it comes to thinking on which approach you want to take, you can kind of think of it from a Marvel perspective, where the left side, a flat denormalized table, is kind of like the Blob. You know, if you're familiar with X-Men, the Blob is a superpower, really massive guy. He's not known for speed. That's not really his approach, but he's strong. He gets the job done. While over here, a relational model is more like Quicksilver, who is really crazy fast, just absolutely fast, which is totally true with what happens in Power BI, where I've had tables with hundreds of millions of records being sliced and visualized in about as much time as I can blink, right? Like it's crazy fast how quickly these relationships can work within Power BI. So typically we suggest go with a relational model. The only case where you should go with a flat or denormalized model in Power BI is if you just have one dumb table in Excel, and it's always going to be one dumb table in Excel, and that's really all it's going to be forever. Then sure, go ahead, just do a flat or denormalized model. Just bring that thing in visualize with it, that's fine. If you have anything that's a little bit bigger than that, basically anything bigger than that, anything that's going to involve more than one table, especially, you should make it a relational model. No doubt about it. So how does a data model work in Power BI? So here's a quick example where I've got these 4 tables. Here you can see I've got a sales table, year table, product table, and a category table. And you see each of these have a relationship that eventually gets down to sales. So if I ask the question, let's see here. This one just froze on me. Okay, here we go. Now, if I'm looking at this data model and I say, hey, from this data, I want to know what was the sales quantity of category A in the year 2018. This is pretty straightforward, and it might be completely obvious to you, but sometimes when you're working with a data model in Power BI, it just doesn't feel as obvious. But let's say, let me back up here. Let's say, so first we're looking for category A, right? So what that does is it's going to select the field or every record with the value category A within the category table, filter down to the next table that has that same category A. You can see here category A, category. So this is my key between these two. It's going to filter product down to just those that associate with the table beforehand, and then cascade that filter down to my sales table. You can see here are the 2 records or rows in my sales table that associate back to category A. Right, pretty straightforward. And then I can say over here, year 2018. Here we are. We finish with the 1 row that meets the criteria coming from all the tables filtered. It seems like this is really, really straightforward, makes a lot of sense. But as you start working in Power BI, sometimes it doesn't feel very straightforward. But this is really what's going on behind the scenes, and it's really this straightforward. Each of these relationships is just like a join, is really what's going on in the background. And so if you speak that kind of language, it's a join. If you speak Power Query, it's a merge. But the idea is really, whenever I run a measure or something like that, it's just going to go through the filters I've applied and grab whatever remaining records there are and summarize whatever value I've told it to summarize, or field I've told it to summarize. Pretty straightforward. So let's jump into the components of a data model. We're going to look at tables, columns or fields, relationships, and measures. And again, we're going to dive into each of those, but this is essentially the components of a data model in Power BI: tables, columns, relationships, and measures. And if you're really bright and you're like, oh, but columns are tables, and you're right, but I call them out explicitly for a good reason. So when it comes to tables, there's fact tables. Again, we're just talking big picture here. These are just big picture concepts that I want to help you understand as much as possible. Part of this is just exposure, where don't feel like you need to learn this all, but it's just like being acquainted with these terms. The more you're exposed to it, eventually it'll just like click. That's how it's worked for me. But we've got fact tables, dimension tables, flat tables, and then there's these other types of tables that we're not going to address today, but they are addressed in the course. And so if you're interested in like, oh, what does that mean? You can dive into that. We'll also in the course talk about how to actually make these things. Like say you just have a denormalized table that you're starting with, you can normalize it and make it a relational model, make that one table a fact table, multiple dimension tables, those kind of things. But let's dive into each of these things. So a fact table, in this case, in this particular model, the fact table is the sales table. Fact table contains transactions or events. You can think sales opportunities, system events. They also typically contain numeric fields that can be aggregated, say sales amount, units, cost, those kind of things. A dimension table, in this particular case, each of these 4 tables are dimension tables. And a dimension table is typically a table that contains descriptive attributes that define how a fact should roll up. So looking at this model, kind of an obvious way to think of this is sales by geography, sales by date, sales by customer, sales by product. But of course, these can be a whole lot more expansive than just saying geography, right? As you can see here in the geography table, we've got city, country, district, region. This zip country is used as a unique key. But date, day of week, month, quarter, year, all different kinds of ways to slice based on these different things, right? But again, these tables typically don't contain any fact information, anything that you're expecting to summarize. Those are generally pushed into a fact table. The customer tables are typically just descriptors or fields that describe the sales or help slice the sales or the facts that are relevant. So a flat table is one table containing all fact and dimensional data. So kind of what we already talked about before, right? A flat or denormalized table would definitely fit this criteria, but essentially a flat table is just any table that has facts and sales on it. This is not, this is just what I call it, because it's important to spot these so you can know when to separate them or transform them into a sales table and or a fact table dimension table. Now let's jump into columns and fields. So we just talked about the types of tables that you should be aware of as you start your journey into data modeling in Power BI. Now let's jump into columns and fields. So first off, fields are, as we look here at this data model, fields are represented by each of these words within a table, right? So zip country, this is a column or a field that is on that table. City, country, district, if we're looking at a spreadsheet, which is really the way that tables look in Power BI as well. So it's nothing too new for most people. As you look at that, you can see each of these columns, and here they're just represented vertically instead of horizontally because it's just easier to read and easier to pack in information into one place. But each of these are columns on the table. Now there's different data types for each of these fields. You can choose these data types either far upstream, where maybe in SQL, if someone's doing some SQL work for you, or if you're doing SQL yourself, awesome. Or whatever language you're using, doesn't really matter. You can define the types before it comes into Power BI, or once it's in Power BI, you define your data types. As you can see here, anything that has this kind of sum symbol on it, or sigma symbol, means that it can be summed. It's either a whole number or a decimal number or something of the sort. Over here is an example of a date, a date data type. So some things it's called out for you, other things not as much in this particular view. But you can have different data types, which matters because different data types determine how much storage is required. And the more that is being stored in your data model, potentially the longer it takes for Power BI to dig through it. That typically doesn't become a problem until you're at a larger scale, but it's something to be aware of so you can avoid that problem down the road. You can also format fields, meaning I'm going to go in and say, even though this has 6 decimal points or 6 integers past the decimal, I really just want this to be 2. I can go and format it so whenever it's visualized, it's always going to just show the 2 digits past the decimal. And there's lots of other formatting options, but just something to be aware of, you can format each and every one as well. You can create calculated columns. So here, down here in this date table, whenever you see this particular symbol, where it's essentially like a table symbol, or this zip country is another example. This is a calculated column, meaning DAX was utilized. DAX, the language of Power BI, was utilized to create this column. Now, ideally, that'll be done before you get to this point, because if you're using DAX to create calculated columns, you're missing compression, but that's kind of deeper than we need to go today. It's just something to be aware of. Calculated columns are explicitly those created using DAX within Power BI. And you can see here those columns that were used with that, or that were built that way. You can also hide fields. As you see here, this is hiding these columns, meaning when it gets down to a true end user, like past the dev, they're not going to be able to see these fields, which is typical use case for anything that you're not expecting people to use at all. Like a key, for example, like this zip country key has no meaning other than just to be utilized as a key. So might as well be hidden. That's one example of that. But again, anything that could confuse or just kind of bog down the user experience, all those fields should be hidden. That's quite easy to do. It's just a matter of right clicking and saying hide, or in this view, just clicking the eyeball like this. There's key fields. Key fields are those fields that are used as keys. I've already brought up the zip country as an example. We'll get a little bit deeper into that once we talk about relationships. But that's essentially, from a high level, all you need to know about columns and fields. These are the kind of fields you need to be aware of. Just kind of another side note, typically when you're running your measures will run against integers or summable columns. And I didn't call that out explicitly, but typically you'll be summarizing these kind of columns or these kind of fields, the ones with the sum or the sigma symbol. So now let's talk about relationships, another important part of a data model. So these lines between tables are called relationships in Power BI. It's a connection between two tables, ideally fact to dimension tables, using one column from each table. So that's a limitation that Power BI brings to the table, is you can't do a join using multiple columns or fields. This can feel like a big limitation for people coming from much more free places. But you can, once you know that, it's not too hard to work with. That's typically what happens. It either means using a bridge table or another table to communicate multiple key kind of requirements, or creating keys that combine keys, like here is zip country is an example of this, where it combines information so that it becomes unique to this table and acts as a good key. Another thing to know about relationships is they call out the key cardinality from the tables, which we'll dive into in a second. The filter direction, meaning which table is filtering which, and also the state of the relationship is visualized here too, which we're about to dive into. So looking at key cardinality. So key cardinality, oh, 1 second. There it is. That should have appeared a little bit earlier. Here, the key cardinality is captured with these particular symbols next to the tables that are part of a relationship. So here I can see this customer table has a 1, the sales table has a star. And I might have gotten ahead of myself here, but this key cardinality applies to keys used on both sides of every single relationship. Every single relationship this is considered. And each key can either be a 1 or many. 1 being represented by 1, many being represented by a star. Now the key cardinality between these two tables largely determine the direction of the filter or the direction of the relationship. 1 will by default filter into the many side. To dive a little bit deeper into this, I don't want to go too deep, but the concept of a 1 side in this case means every value that is used as a key in the customer table is only represented 1 time. They are all unique on this entire table, meaning I've got a unique key for every single row. So in this case, customer ID is likely my key here. That means I have every customer ID value on this table is only happening 1 time. There's never a repeating value on my customer ID. And then over here in the sales table, this customer ID is repeating it at least 1 time. 1 customer ID is happening more than 1 time, or shows up more than 1 time in this table, which if you think about it, makes perfect sense for a fact table. I've got so many sales, I would expect at least 1 customer to come back again and have multiple sales, right? Have at least 2 sales, 1 customer, at least 2 sales. So this is typically the relationship, how it works from coming from a dimension to a fact. A dimension will be on the 1 side, a fact will be on the many side. So this is an expected relationship there. there's a lot to get into there, but let's keep it pretty simple. So filter direction, every relationship has a direction, as demonstrated by the arrow in the middle of each relationship line. And again, it determines which table is tacked on or joined or merged to which. The idea, remember that original demonstration that I showed, if we wanted to have sales of a certain customer, we would filter the customer table, and then through this relationship, using that customer ID, it'll filter down the sales to just those sales that related to the customer of choice, or whatever dimension of a customer or a descriptor of a customer I'm interested in. So if I only want to see those from the state of Nevada, I can filter the state here on customer, and that'll filter down to sales. And that's because my directional relationship allows me to do that. If I was filtering the other way and I filtered on customer, my sales wouldn't change. That's essentially what that means. So the default is one direction, but you can have it point both directions. Typically, you should avoid that unless you know what's going on. We're not going to go deep enough into this particular session to say I know what's going on. So just avoid them when you can. Try to keep them one direction when possible. Let's talk about the state. So there is a state of relationships. In this case, all of these are hard lines. But if this were dotted lines, that would mean it's an inactive relationship. So only active relationships by default affect visuals. Meaning if this is an inactive relationship and I go and choose Nevada as the state of customer, it is not going to filter my sales by default. Not at all. It's going to have no effect on my visuals whatsoever. If it's active, yes, that'll work in the back end, in the background. With inactive relationships, the idea is you can use DAX to activate it when you want to. So I could potentially have multiple relationships happening at once between two tables, and then just in certain scenarios when I want to activate it, I'll trigger it within DAX using a calculate statement. That's again deeper and kind of off topic, but the idea is you can have active or inactive relationships. Sometimes you'll create relationships and not mean for them to be inactive. And usually that happens when your model is confusing you in some way, because you can't have one table. Again, your model should just be as straightforward as what we're seeing here. If you've got a table filtering two tables that then filter the same table afterwards, Power BI is going to say, no, don't do that. You can't do that. And it'll inherently give you inactive relationships. And that's when you need to start thinking through, okay, that doesn't actually make sense how I'm trying to filter it. Or I can understand why Power BI is having a hard time, because I'm saying filter through two tables, which is going to contrast and not really work together, so it won't know how to prioritize. In the end, if you get inactive relationships that you weren't expecting, it just means you need to think through what's going on. So what is a measure? And what is the benefit of using a measure? So this is an example of a measure where within Power BI, if I go and create a measure, first I want to identify the table I want it to be associated with. So typically what I do is go to the table I want to be stuck onto. Ideally, it's on a measures table, which we didn't even talk about today. But if you know what that is, awesome. If you don't, cool. You can just look it up. Concept being, I want to keep my measures in one place. But nonetheless, what a measure is it's really, it's a DAX calculation that on the fly is calculated within my visuals and pulls the data in that I want it to. Now the benefit of using a measure, so another call out is whenever you see this particular symbol in front of a field in your fields pane, that means that it's a measure. The benefit of using a measure is instead of calculating everything beforehand and just dropping it onto my model, which takes up space, right? Everything that I add to my model, every time I add a column to my model, it's adding more and more space, or taking up more and more space, I should say, which means, again, as I do queries against it, it means there's more data to look through just by nature of how queries work and how that all works. So if I can avoid adding columns, adding more data to my model, the better off I am, because there's less data to search through whenever I'm doing queries against my model. And a measure allows me to get those numbers without adding them to my model. Instead, all I add to my model is just a line of code. And then those numbers are calculated on the fly at the time of a visual refresh, which means as I'm going onto a page in Power BI or as I'm refreshing a page in Power BI, rather than keeping that data on my model all the time, whether I'm using it or not. It's very efficient, and typically it runs really well. If you have a good data model, measures tend to run quickly as long as they're not outrageously complex. That's the idea. So some people might think, if you're really familiar with measures, you might think measures aren't even a thing. They don't involve the data model and measures, totally different thing. Cannot stress enough that those are actually very, very similar things. What your data model says is what dictates how you write your measures. That's how it should be. But also the code that you're writing for your measures is actually tacked on to your data model behind the scenes. And so it doesn't add a lot of space, but it's actually part of your data model. Now, what are the components of a data model? Just a quick summary. We've got tables, columns, fields, relationships, and measures. So hopefully that at least gave you a good rundown on what's going on there. Now, what are the characteristics of a good data model? So kind of going back to what we said before, a good data model is performant, meaning it has fast data model refreshes. So kind of the back end as I'm pulling data into Power BI, that goes quickly. And then my page and visualizations refresh quickly. This is something I want as well as all of my end users, I'm sure. It also kind of sets the groundwork for fast development, meaning if I need to go and build a report off of a data model, if the data model is built well, it shouldn't take me a long time to develop a new report, because I know exactly which fields I'm looking for, which measures I'm looking for. I know where to find them. These kind of things that lead to fast development. They're also user-friendly. So a good data model is simple. And I don't have really complex relationships going on. It's accessible, understandable. I've got things named in a way where kind of any business user who's somewhat familiar with the data knows exactly what they're looking at. And then ultimately, another important piece is that it meets business needs. So a good data model kind of predicts what future reports are going to be built. And so that when people are going to build them, the data is already there and ready for them to put together. So understanding Power BI performance, already mentioned this, but it's worth bringing up again. The three main influences on Power BI report performance when using the import model, which is what we've been discussing today, is your data model size. Again, how many rows and how many columns and how many tables you have. The data model infrastructure, like your relationships that we discussed previously, and the complexity of the queries that you're running against that data model. So really everything comes back to your data model when it comes to performance. So if you've got a Power BI report that is not performing very well, chances are it's your data model's fault, or the complexity of your query is something to consider too. You've got a client who they just have pages of hundreds, maybe not hundreds, but dozens of visuals that have thousands of data points on them. And if that's the case, the complexity of your query, really the immensity of your queries is what's slowing things down, where you're expecting Power BI to refresh thousands and thousands of data points all at once. And for some reason, it's not going very fast. So part of that too is how you're executing these complexities of your queries. So even if they're not complex, if they're just an enormous amount of data that you're expecting to be pulled, And to kind of dive deeper into that, I'm probably getting a little winded on this one, but when I say data points, I'm saying, let's say you have a 10-year timeline and you're having every single day represented in that 10-year timeline. That means every single day is going to be sending a query to your data model, every single day, because you need a number for each of those days. Now, if I were just doing it by year, right, that would just be 10 queries that are sent. Quite a bit different, right? So just something to be aware of. you just want to be aware of how many data points you're trying to grab within your visuals and how many visuals you have on your page, because all of those are going to run simultaneously, not technically, but they're all going to run around the same time. And that means there's a lot of querying going on, just something to be aware of. No matter how fast Power BI is, if you're asking for thousands and thousands of queries to be sent at the same time, you're just asking for a world hurt. So maybe that means I need to update this slide, but nonetheless, it all comes back to your data model and ultimately the complexity of your queries against that data model. Make a data model performant. Minimize your model size. You can do this by minimizing your data. Essentially, the first thing I do when I pull data into Power BI is I get rid of columns or fields that I know I don't need. That's just step one. You can also do the same thing with rows. If you know there are certain rows that you don't need because all of the data is zeros or whatever it might be, just get rid of any data that you know you don't need. That's just the first step into minimizing your model size. Use measures instead of calculated columns. And I'm not talking just calculated columns within Power BI. I mean, anytime you're doing calculations before coming into Power BI, if you can run a measure to get that data, then do that instead, because by doing that, you can minimize the number of columns you have and the number of values that you have taking up space in your data model. Use a date table. I'm not going to dive too deep into that, but you should definitely use a date table. Streamline your model infrastructure. So use performant relationships, use a star schema. We'll get into a star schema in just a little minute, but relationships where you have many-to-many relationships, bidirectional relationships, these are less performant than one-to-many, one-directional relationships. Those are as performant as you can get into each one of these. When it comes to minimizing your data, again, all data in your model uses memory. So think that through whenever you're pulling data into your data model, it all uses memory. And so you want to minimize that as much as possible. So you want to start with the end in mind as much as possible, meaning I know what data I need to visualize. Therefore, I'm only going to bring in the data that is equivalent, that is required for visualizing that. And obviously you want to think maybe a little bit past just this project. Think through what will I need to visualize soon and bring that in as well. But only keep data that support that end that you decide on. You want to aggregate your data to the lowest granularity required. So let's say you've got daily data, but you're never going to look at it at the daily granularity, and you know that, and that's true down the line of future reports. Then you can aggregate it up to the month, which means you're going to reduce the amount of records you have significantly. You can normalize your flat tables, meaning I'm going to take my flat tables and break it out into relational tables or dimensions and facts so that they can relate back to each other. The reason why this reduces data is, so remember those dimensions, how they're all on the one side. It means if I have a flat table or a normalized table, I have all of my dimensional information being represented every single time a new sale is made. I have this like product name, all these longer text names tacked onto every single fact record. So you can tell that bloats your numbers quite a bit. So instead, what you do is you take those, dimensionalize them, so they go into a table where they're only showing up one time, right? So I've only got my product name showing up one time for each product in my entire model. And then a key is what's going to kind of share that information down at the fact level so that I don't have to have those values repeating so many times. Again, if you don't get that, that's fine. I'm just trying to give you some basic concepts. In the course, we dive a lot deeper into that and show you how to normalize a flat table. But this is a great way to minimize your data. You also want to use surrogate keys. Oftentimes, keys that are provided by sources are like GUIDs, which are just huge text files or text values, which take up a lot more space than an integer would. So by switching keys, you can reduce quite a bit of space too. And keys, typically you have a lot of keys, right? Especially on your fact tables, which typically you don't need keys on your fact tables, but or at least primary keys. Sorry, getting a little too deep. But ideally, your keys are just integers. They take up a lot less space, and they're also much better for joining. And utilize compression. In the course, we dive deeper into how compression works within Power BI. We won't today. Maybe we will. Let me give me a second. Okay, yeah, we will just a little second here. So what is data compression in Power BI? Again, we're not going to go too deep, but essentially data compression is the process of reducing the amount of memory required to store your data in Power BI, and compression occurs as Power BI pulls data from Power Query. Power Query is kind of like the sister tool within Power BI that does the data pulling and some data transformation if you're interested in that. But that compression process happens as it goes from Power Query into Power BI. And it happens during that refresh process. So as your Power BI desktop file or your data set refreshes, it compresses the data as it comes in. Now, how does data compression work? We're not going to dive into that. But man, I'd love for you to know. It's super cool. Data can be, I've seen it compressed over 50 times, meaning I have 100 gigabytes of data that I'm pulling in. And by the time it's done within Power BI, it's just 2 gigabytes kind of concept, which is a huge win because it means your model's smaller and it means it's more searchable. That's the idea. But yeah, take the class if you want to learn more about compression or look it up online. Really cool stuff. Use measures. We talked about that. Measures only store their code calculations on the model, unlike a calculated column, which stores every single value on your model. So it saves on the size of your model significantly. But they also perform essentially the same as long as it's written well as a calculated column, meaning, or any column that was calculated prior to coming into the data model. Same case. It should function or calculated at about the same pace, as long as it's written well and your model's good. So you want to use a date table when it comes to having a performant data model. So Power BI creates invisible date tables by default. So you can kind of imagine I've brought in 7 tables, and on those 7 tables, each of those have like a created date, an updated date, a submitted date, whatever it might be. Oftentimes, tables will have multiple date columns. And what Power BI does to try and be nice to new users in Power BI is it creates invisible date tables for each of those columns, is essentially what happens. So that, you know, I can easily look at things by month, by year, and stuff like that, which wouldn't happen otherwise because I'd be stuck to just the dates that I have selected, right? So it's a functionality that's really nice, but it does bloat my model and slow things down a little bit. It's usually in the extremes that it really slows things down, but it's something to be aware of, so you can just never touch those kind of extremes. With a date table, you can effectively disable this feature, this invisible date table feature, so that those invisible dates disappear. This reduces the data in your data model, which is great, and that didn't make much sense. But so let's talk about using performant relationships. Why do some relationships affect calculation speeds more than others? Some relationships provide a poor infrastructure. So when I've got a many-to-many relationship, there is a lot more to that join going on in the back end that complicates that relationship quite a bit. And so it requires Power BI to think more. It makes it, more compute is required to understand the relationship. And so it slows things down a little bit. Another example is the direction of a relationship. When it's bi-directional, it has to consider, okay, so which direction are we going right now? And again, this too kind of comes down to how the join happens upon calculation. It's a more complex join that's going on in the background. So again, it has to kind of navigate what's going on there. Another thing to consider is the number of relationships traversed. So ideally, you'll work in a world where you just have fact tables and dimension tables, and you just have relationships between your fact and your dimensions. From fact to dimension, never to dimension, or fact to fact. That's the ideal way, because then every filter you're doing is just going through one single relationship. Now, if you have what's called a flake, which is a dimension upon a dimension, which was in the original example I gave of how models work, you're now requiring Power BI to navigate 2 relationships, right? So 2 joins need to be done in order to explain or to capture the filter data that you are looking for. So ideally, minimize the number of your relationships. If you have a flake, ideally you can merge that back into a dimension, stuff like that, so that you can reduce the number of relationships that need to be traversed. And then there's this kind of complexity concept that I've already kind of mentioned. Again, one-to-many is ideal. Many-to-many just complexifies a relationship and just requires more compute for Power BI to think it through. So ideally, you want to use a star schema every time. And star schema can be hard to implement. It can be difficult, and it'll take a little bit of work to understand how to make this work for you every time. But this should be your goal every single time you make a data model in Power BI. You should be building a star schema. And essentially what a star schema is, so this particular one that we've been looking at is a star schema. And the reason why is we have clearly identified fact and dimension tables. As we already mentioned before, the sales tables, the fact table, the rest are dimension tables. All the active relationships are between fact and dimension tables. So there's never an active fact to fact or dimension to dimension relationship. You can see I don't have relationships between my dimensions here. I've built it in a way where I have my sales kind of navigating the relationships between each of these dimensions if needed. And that's a little bit deeper. Not going to get into that, but so we've got, so all the active relationships are one-to-many as well. As you can see, that's the case here. One-to-many, one-to-many. And all the active relationships are one-directional. So nothing is bidirectional. It's always from my dimension to my fact. And now I could have several of these star schemas represented, or I could have several fact tables. And as long as these things are still true, where I've clearly identified my fact and dimension tables, and all of my active relationships are just from dimension to dimension, they're all one-to-many and one-directional. No matter how many fact tables, no matter how many dimension tables I have, that's still considered a star schema, or a galaxy schema is what some people might call it. But the idea being, it's mostly about how these relationships are set up and kind of how many relationships. I don't have any flakes, again, meaning I don't have another dimension that hooks to a dimension right here, right? I just have just one level of dimensions and facts. And all of my relationships are from dimension to fact, never a dimension to dimension or a fact to fact, never many to many, ideally. There are some use cases where that's appropriate. Not going to dive into that. No bidirectional relationships. Again, there are use cases where that's appropriate. If you don't know what those use cases are, just don't touch it if you can avoid it. So how does the star schema improve performance? So it provides a structure that minimizes inefficiencies. We kind of talked about those relationships, minimizes those non-performant relationships. It reduces the size of the data model through the use of normalization, which I discussed briefly, but these are really big deals. Star schema is just absolutely where it's at with Power BI. Strongly suggest you start that direction of figuring out how to build those star schemas. Now, how to make a data model user-friendly. First, you need to understand your end users and their requirements. Use user-friendly names. So oftentimes, if you're someone who's done a lot of development with data, you'll have a lot of underscores, camel case, whatever it might be. By the time it gets into Power BI, it should be completely friendly. Just use spaces, use capitalization as appropriate, whatever it takes to make it as friendly as possible for end users. Organize your tables, measures, and fields in a way where it's a lot easier, that's intuitive for your end users. Use a star schema. You might think using a star schema actually doesn't seem like it'd be that helpful. Really, it just categorizes your dimensional concepts is really the idea, where it's actually quite useful. So if I had one big denormalized table, I would have every single field on one table. If I can break those dimensions into concepts, so like geography, for example, customer, for example, breaking these into concepts and literally breaking them into different tables actually helps end users find what they're looking for quite a bit faster. They might need a little bit of training to be like, hey, it's broken up into these different tables. Sure, there might be a little bit of that kind of hand-holding required initially, but it eventually makes it much easier to understand what's going on. And then you'll want to minimize your data, meaning either remove that data, filter it out, or hide the data that's just going to be confusing for your end users. Meaning any field that maybe has a similar name to something else, or any field that you just don't want them to touch, but you need for some reason within your data model, just hide that kind of stuff. Again, just to guide your end users to the easy stuff. And use date and timetables. I didn't mention timetables previously, but the idea is a date table is a date dimension, a time table, in this case, is a time dimension, meaning I can easily slice by morning, afternoon, by 7 p.m. or whatever it might be across my facts. Just another really easy way to, if your reports have some kind of time element, just an easy way to make it really sliceable for your end users. And then just a best case scenario is when you're thinking about how to design your data model, just get your requirements and make them really, really thorough so you can build your data model in a way where you don't have to go in and tweak it all the time, right? Like you need to know what questions are your end users attempting to answer, what data is needed to provide those answers, and work back from there. And then how will the data answer those questions? How should or will the answers influence their behavior? And what does the end user call the data? Like if you actually know what they call it, then you can just name it that and boom, good to go. So these are just kind of things to think about as you're gathering requirements. In short, if you do a really thorough discovery, you can have a fantastic data model that is user-friendly and meets business needs for a long, 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 long time to come, which is fantastic. Love building stuff that lasts a long time and that is going to stay performant and stay relevant for years to come. When it comes to the BI space, that might sound like a pipe dream. I bet a bunch of you have already switched tools tons and tons. Power BI is here to stay. And if you build fantastic Power BI data models, those are going to last you and your company a good long time. When it comes to user-friendly names, again, rename tables and fields for quick recognition. Use the business nomenclature, use spaces, title case, capitalize each word kind of thing. When it comes to organizing your tables, just organize them in a sensible way with clear titles. Create and use a measures table, which is essentially an empty table. It just stores your measures. Again, we didn't dive too deep into that, but you'll want to organize your measures and fields within folders, which is just a kind of a metadata way to make things even easier to understand. And again, we're not going to dive in how to do that. If you're interested in that, I'm sure you can Google that. It'd be just fine, or take the course. Hide confusing and useless tables and fields, already mentioned that. And then when it comes to using a star schema, we've already mentioned exactly what a star schema is. It's literally worth saying again, because it's that important, where it's a model where all of my active relationships are from a dimension to a fact, never a dimension to dimension or fact to fact. They're all one to many, and they're all one directional. So they all have one to many. They all have one arrow pointing from a dimension to a fact. And it doesn't matter how many fact tables I have, how many dimensions I have, as long as my relationships meet these standards, this is a star schema for all intents and purposes for Power BI. And if you set it up this way, it tends to be very, very intuitive for users, because these are just kind of buckets for dimensional concepts. And there you have it. So again, minimize your data, get rid of unnecessary data, hide the data that's not useful. That way you don't confuse anybody. And then use date and timetables. This way, it's just so everyone wants to slice by time, and it's so nice to have so many options on time, whether it's a weekday, whether it's a weekend, whether it's a holiday, whether it's these different things. These are the kind of things that you can establish in a date table. And that'll just make it really easy for end users to slice by those kind of things. And then on a timetable, you can do the same kind of thing, where it's easy to slice by morning, afternoon, evening, hour of day, etc. If you don't have a date or timetable, happy to talk with you and help you build those. pretty straightforward stuff. Once you have it forever. And really a game changer for making your models more user friendly. All right, that is it. That was a lot of talking. Hopefully everyone came away with some good stuff. Again, it was meant just to be kind of cover the overall concepts. If you want to dive deeper into it, please take our course. We'll make sure you have a link to that shortly. But thank you for your time.
Thanks, Josh. Much appreciated. That was fantastic. I put the link to our survey into the chat. Please fill that out before you take off and hit up the next session. That gets you into the drawing for the $50 Amazon gift card and also for the Surface Pro 9 as well. I think we have a couple minutes for, if you have any questions, please put them into the chat, but also please reach out as well after this. We're here to be a resource for you. And for those that are in Utah, I think we have that Topgolf happy hour tonight. So hopefully you can make it out there as well.
Yes, please. That'd be awesome. All right. Any questions? We still have a minute. I'd even stay after because you all are still here, which is awesome. You bet, Tyson. You bet. Cool. Thank you all very much. Yes, John. Yes. Love it. All right. Well, enjoy the rest of BTS and come to Topgolf if you can. Good to see you. You bet. Thanks, everybody. It's been a pleasure. Oh, it looks like Debbie does have a question. Debbie, if you've got a question, can you drop it in the chat? I think we've got everybody muted, so we wouldn't be able to ask that. That is a good question. Are you asking specifically for the slides, Debbie, or what? How would you like to consume this info again?
Hey, Debbie, I think as long as you fill out the survey, I think we will be able to get you the recording after or sometime later this week. So make sure to fill out the survey and we'll make sure to get you the content.
Might change.
No worries.
Cool. Yep, Debbie, it's recorded. So
yep.
If you fill out that survey, you'll get the video. It sounds
Here,
like
I'll put the survey in one more time.
Monday. Session recordings will come your way.
On Monday, nice.
A strong promise. Strong promise from Mariah.
She's committed now.
That's right. You bet, Debbie. Thanks for joining. Got here just in time. All right, I think I'm just gonna chill here for, I don't know, a couple more minutes. Just to be thorough, just in case. One
Can't
of you
hurt.
is like, oh, there's that thing I just don't want to say it. I don't want to say it. It's gonna be so embarrassing. Or right now you're typing that chat and it's like the question is like 3 paragraphs long or whatever. I get it. Oh, I did not see that question. Thanks, John, for bringing that up. Unfortunately, I can't demo that right now, Braden. But essentially the idea is you'll just do an enter data table and leave it blank. Call it something like measure, or have whatever your nomenclature is, and bring in a blank table and then just put all your measures on that table. And then hide your blank column, and then it becomes a measures table. Like it actually will jump up to the top of your fields pane. It'll be the top table. And then if you just stash all your measures there, it's just an easier way to kind of track those. And if you want to folder them, what you'll do is you'll go into the model view, select the measures you're interested in, and there's in the next to the field pane, the next pane next to that within the model view allows you to give it a display folder name. And you can just multi-select whichever ones you want to put into a folder and just put the display folder name, and it'll automatically add that metadata tag and just put them in a folder in your fields pane. That's kind of a lot to throw down like that. But it's also a concept that is online as well. So if you were to Google that concept, like use a measure table in Power BI, I'm confident you can find the documentation on how to do that. But again, it's pretty straightforward. It's just a matter of creating a blank table using enter data, or whatever method you want to use, I suppose. But having a blank table, putting measures on that table explicitly, which you can do by selecting your measures in the field pane and saying which table is the home table. That'll be up in the ribbon. Or you can do that in the model view as well. And then going to the model view, selecting your measures, adding a display folder name, and that's how you can create folders for each one. There's a little bit more to that, but that should do the job. You bet. Thanks for catching that, John. All right, cool. Well, thanks everybody. It's been a pleasure. Hope you enjoyed your time. Hope you learned a lot of stuff. It's quite the journey figuring out Power BI data modeling. So got someone that has your back. You're gonna do great. Can't wait. All right, see y'all.